and teachers. Welcome to our second of many, I think 4 or 5 environmental science content review sessions to help you get ready for the AP exam that's coming up, and I hope you're enjoying these. Again, my name is Lou Akampora. I'm the Science Director for AdvanceKentucky, and our host today will be Rob McCann, presenter from Harrison County High School. Just a few notes. Please make sure you're muted and your video is turned off. Feel free to use the chat box to ask questions, or when our presenter might pose a question or two. This presentation will be archived at the kyap2020.com site, along with other resources that I hope will help you prepare for that, that exam. I know many of you worked hard to earn college credit, and we want to help you get that. So let's get started then. Rob McCann from Harrison County High School has taught environmental science, is there for many years. I won't say how many, Rob, but also acts for the NIMSI, National Math and Science Initiative, Environmental Science as a consultant. And he will be talking to us about climate change. So I am going to turn the screen over to him.
Hey guys. I have been teaching AP Environmental Science now for 12 years. That's crazy. And all of them have been with AdvanceKentucky, so it's pretty awesome. So today we're going to talk about climate change, and we're going to interact with the chat box as much as we can. You guys can ask me questions, and you can tell me how awesome things are going. Just stay interactive, okay? The topic today, so we're going to switch over to our screen share, and we'll see what we got here. All right, you guys seeing this? Check this chat box here. All right. Okay, so this is CRS session number 2 here for climate change for AP Environmental Science. And we're going to start off here by talking about what climate change is not. Okay, oftentimes there's a misconception that climate change and global warming, or climate change and sea level rise, or depleting ozone layer, or the greenhouse effect. We need to make sure that we know that climate change is on this list. Okay, it's not a part of any one of these, and it's not, these aren't causing. Okay, climate change is its own entity. Okay. So global warming is an issue, right? Just like climate change is an issue. They're not one and the same, okay? So you wouldn't have a question that talks about global warming and then you use climate change to describe that. You need to be really, really careful. I'm not saying that the things here on this list here are not related and in some part to climate change, but they are not the same thing, okay? So in other words, you wouldn't say, depleting ozone layer is causing climate change, or climate change is causing a depleting ozone layer, okay? So be really, careful, because now we're getting into the situation where, your free response question has to be specific, okay? You can't just, shout out the word pollution and then expect the reader to understand that, oh, well, that person's talking about eutrophication, or that kid is talking about, a fertilizer that is runoff that, pollutes water. Okay, so you have to be really careful when you're trying to explain your answers on these free response questions, because that reader is not your teacher. And see, sometimes that's the issue. As a teacher, when I read my students' responses and I see my students in class, I oftentimes give them the benefit of the doubt. And that's why this mock reading that's coming up, this mock exam is very important. So if you're not participating in that, you need to do so, very much so, because you're going to have someone else look at your answers, and that someone else is not going to be your teacher, and you're not going to get the benefit of the doubt. So you're going to have to be you're either going to be right or you're going to be wrong. Okay. All right. Any questions about that? If you have any questions, again, just go over to the chat box for me. Okay. All right. So when I teach climate change with my students, I go with the KISS approach. And I'm not sure if you know what that stands for, but you know, in essence, it's keep it simple. And then you can add, you know, a silly is a more appropriate term. So keep it simple, silly, if you want. So right now we're going to start off here with the chat box. Go to the chat box and just give me a one-word definition if you want, maybe a short definition. Define climate change for me, okay? So go to the chat box, type in real quick. You guys are going to have to be really quick at typing because you know your exam is going to be a 45-minute exam. You got just a short amount of time to type your answers. So what do you guys, so start typing in the chat box. Define climate. All right, what we got here? Climate change over time, climate changing over time. Yeah, we got some good responses. Is weather over a long period of time? And all right, good. For some reason, when I go to my chat box, it's not showing it to me as readily as I'd like it to. That's okay. All right, so our KISS approach here, go back to your chat box and type in, what are two big things that determine a region's climate? There's two really big things that we look at. Maybe in your class, you guys did a climatograph where you graphed these two things, okay, where you had the double x-axis, okay. All right, now we're rolling here, temperature and precipitation, very good. All right, so now that you've identified climate as really two things, okay, temperature and precipitation, okay, that's key, and that's the keep it simple approach, okay. So let's not think of like this, you know, huge, you know, overwhelming thing. Really, climate change comes down to two simple things: a change in temperature or a change in precipitation, okay? So we go down to define climate change and we see this, okay? And it says here, climate change refers to any significant change in the measures of climate lasting for an extended period of time. In other words, climate change includes major changes in, and I underline these because this is where I want you to focus, a change in temperature, precipitation, or wind patterns, among other effects that occur over several decades. Okay, remember, we define climate change as some sort of annual precipitation or temperature over a 30-year period. Okay, that's why, you know, that one of those cliche questions that your teacher might ask, hey, what's the difference between weather and climate, right? And you all say, the masses say, well, weather is day to day, right? And of course, we're all here in Kentucky right now, and you guys know that weather here changes in a 24-hour period very quickly. So, but climate, though, is a little bit different because that's the annual precipitation and temperature over a long period of time, okay? All right, questions. I'm checking the chat box here. Good, temperature, precipitation, keep it up. All right, those are really quick responses too. Hey, do you understand what I'm saying? So again, I want you to focus on these two things, the change in temperature and or the change in precipitation. And that's where we're gonna be, okay? All right. So how can precipitation change? And look, we have that cool everybody knows and loves the elementary school level water cycle, right? And so this is one of our biogeochemical cycles, right? Okay. And so this is the water cycle. So rush over there to your chat box there. What are the water cycle terms? You know them and love them. So start typing those in there. In the chat box, you're typing any of those water cycle terms that you know and remember. And I've gone through and covered them up here because you should know them, right? Good. We got some influx of some responses here. We've got transpiration. Good, because I put the one that plants do that everyone seems to forget, at least my students. Oh yeah, see Stephanie, I see you put there's transpiration. Okay, good. All right, so all of these things are part of the water cycle. So when precipitation rates change, they could be a change in one of these steps to the cycle. Okay, so let's back up. We're talking about climate change and we're taking the keep it simple approach. So we're either going to talk about a change in temperature or a change in precipitation. So when I look at the water cycle, these are the possible changes that could be climate change, okay? So it could be an increase in the rate of evaporation, okay? It could be a decrease in the rate of evaporation, okay? It could be an increase in surface runoff, a decrease in surface runoff, okay? Those are some things that are going to happen when we are trying to describe climate change, okay? Infiltration, percolation, good. You guys are killing it. Good job, Leslie. Welcome to the group.
Rob, there was a question about groundwater too and where that was in the water cycle.
Okay. Groundwater. Okay, the question was actually answered in the chat here. What groundwater is as it moves through the ocean. They're looking for what's the groundwater ocean called, and that would be percolation or infiltration. Okay, so thanks, Leslie and Jay. Will you guys answer that question in the chat box for us? Okay, so and then if you don't know, percolation is the term used for groundwater actually moving through the ground. Okay, it's called percolate. All right. Okay. Any questions so far? So we're talking about climate change. It's either temperature change or precipitation change. And when I'm trying to describe climate change in relationship to precipitation changes, I'm talking about the water cycle, okay? Now, what's another word when talking about the study of the water cycle? This was a term that, let's see, when I was teaching in 2009, my students were just mind blown because the FRQ, the exam creator, they did a different term to describe the water cycle, and it threw my good hydrologic. Very good, Brenda. Hydrology, waterology, close, but we're going to go with hydrology. Okay. All right, keep participating in the chat box. Okay. All right, so listen to me. In 2009, when they saw this on the free response question, the word they used was the hydrologic cycle or hydrology of the Colorado Rocky Mountains. And we're going to look at that question a little bit later, okay? But for some reason, my students just went completely blank on what hydrology was. And that's just a really fancy word for the water cycle, okay? All right, so we talked about climate change and precipitation. Let's look at climate change as it relates to temperature. Okay, so we got this graph here, thermal imaging of temperature. And so we get seasonal variations in temperature. Okay, we've got 4 seasons, you know, spring, winter, summer, fall. Okay, we have the tilt of the axis. And when we're talking about the tilt of the axis, we're talking about whether we're getting the northern hemisphere is tilted towards or tilted away, okay, from the sun. And so that changes the impact of solar radiation, okay? So, you know, if we're tilted away, we're getting more of a glancing blow of solar radiation. And when the northern hemisphere is tilted towards the sun, we're getting more direct sunlight. And so that gives us our variations in temperature changes, okay? Another big factor here that plays into temperature changes is this word called albedo. So quickly run over there to the chat box for me. I know I said run over there like you're actually running. But what does albedo mean? Okay, the Arctics are still cold because of the albedo. Yeah. The percent of sunlight reflected. Very good, Stephanie. Reflection of the sun, reflection from the snow, sunlight reflected. All right, good. These are all really good. Okay, so albedo refers to the reflectivity of sunlight. Okay. Another big contributing factor to temperature would be the greenhouse gases. Okay. And so we know that the greenhouse gas effect, okay, or the greenhouse effect, there is the natural phenomenon of the greenhouse effect, okay? And that natural phenomenon is why our temperature on Earth is what it is, okay? Without it, let's do a poll, Lou, if you would. Without the greenhouse effect, would you say A, Earth will be colder, or B, Earth would be warmer? Without the greenhouse effect, what would happen to Earth's temperature? Would it colder or warmer? A, colder, B, warmer. Good. All right. Lou, you could.
Okay, we've got about half the respondents.
Yeah. You can end it. That's good.
Last guesses, I'll give 5, 4, 3, 2, and a little more than half the people voted.
Yeah. Hey, guys, listen. The Earth would be so much colder. So much colder. Okay? And it's because of our greenhouse gases that we have, they actually trap that solar radiation. They trap that heat here on Earth's surface, and that is what contributes to our temperature. Without it, it would be much, much, much too cold for us to survive here on the planet, okay? All right, so those are some things that contribute to our temperature, all right? So we're talking about climate change, we're talking about a change in temperature, or like we said earlier, a change in precipitation. All right. Just a little trivia question there. Why is there like a distinctive little color change right here? Go to your chat box real quick and tell me what's going on there. What we got here? Okay, reflection of white. Okay, I'm checking the chat box here. Backwards, okay, El Nino, good. I don't know, good. Hey, it's El Nino, okay? Remember, if we're gonna talk about something that's like a global, say, instance in climate change, we're talking about El Nino right here, okay? We are in the Pacific Ocean, okay? We're off the coast of South America. We're, Peru, Chile, okay? And we're getting those, what prevailing wind pattern are we getting in this area? I know I'm going off script here, but this is all relevant. What prevailing wind pattern do we have here? Okay, it's not a Coriolis effect, but what of our prevailing winds? So you really have three choices. You have westerlies, you have trade winds, or you have polar easterlies. So which prevailing wind pattern is prominent right here? Prevailing wind pattern.
Shall we launch a poll?
Yeah, let's do a poll. A, B, and C. A will be, we'll start from the north and go south here. So A will be polar easterlies, B will be westerlies, and C will be trade winds. So you can do A, B, or C, polar easterlies, westerlies, or trade winds. Good. Keep them coming.
Five more seconds here.
Yeah.
3, 2, 1, and I don't know the answer to this, so.
Okay, it is our trade winds. So
Excellent.
if we look at the southern hemisphere, we have what are called the southeast trade winds, okay? Because El Nino, and you guys were right in the chat box that said El Nino, that's what's going on right there. And that little blue line there, we're seeing the southeast trade winds are taking water, okay, surface water, and they are, they're moving it. That prevailing wind pattern is blowing it over here to the Indonesia, Australia area, okay, and that's what's going to give them their predominant climate patterns where they get a lot of thunderstorms and a lot of rain because that warm, moist air is just going to condensate and dump right there. And that's why, rice and sugarcane are their gross domestic products, right? Because those types of agricultural crops require a tremendous amount of water, okay? Now, Brenda has thrown in Hadley cells, okay, which is very, very good of you, Brenda. Thank you very much. So what is the difference here? So I said prevailing wind pattern, but what is a Hadley cell? This is also a Hadley cell. So we have two things going on here. We have a prevailing wind pattern called the trade winds, and then we have a convection cell called the Hadley cell. All right, so if we kind of flash back to, how can we transfer energy, right? We transfer energy by conduction, convection, and radiation, right? So if the Hadley cell is a convection cell, that just translates to warm things rise and cool things fall, repeat, right? That's the transfer of energy is called a Hadley cell. So the energy here, we have a prevailing wind pattern, okay, southeast trade winds, and we have them moving in a loop, a convective loop called the Hadley cell, okay? Now, Stephanie up here in the chat box says something about the Coriolis effect. Okay, Stephanie, the reason you would like to talk about or mention the Coriolis effect is just that this wind pattern is not in a straight line because the Earth's rotation causes it to curve. That's the Coriolis effect. All right, so let's get back to the topic here, the topic at hand. Okay, so we're talking about climate change, right? We're talking about, and I'm talking about the keep it simple approach where we talk about a change in either temperature or a change in precipitation, okay? All right. So one major driving force in climate change is this graph right here, okay? Now, the solid zigzag line here that you see, okay, that's the Mauna Loa Atmospheric Observatory in Hawaii, okay? And you're seeing global concentrations of CO2 in parts per million, ppm, okay, parts per million. If I could stop for a second and just tell you, sometimes what you're gonna find on this AP exam is a vocabulary lesson, okay? And so the more you can inundate yourself and, swamp yourself with knowing vocabulary, like ppm, what that stands for, the better off you're gonna be, okay? All right, so here we have CO2 levels and parts per million. This is global. Now, we're using the Mauna Loa Observatory in Hawaii, all right? And we use that location because it's unbiased, okay? Yes, New York, Los Angeles, Japan, like Tokyo, those places are gonna have the technology, probably way more advanced technology than you may find at the Mauna Loa Observatory in Hawaii, but those places also have large population densities. They have large industrial sites, and so you have a biased carbon dioxide emission, okay, in that location. And so that's why the Mauna Loa Observatory here in Hawaii is unbiased because you're an island out in the Pacific Ocean, and you're gonna get unbiased results, okay, of global carbon dioxide emissions. All right, so we see here that it's increased, and it's increased because of human-generated practices. And so the AP exam, they often use a different term for human-generated. So go over to the chat box and tell me, what is the term used to describe this human-generated component? So I'm looking for you to define for me human-generated. What is that word that we use that means human-generated? Good. Anthropogenic. I see it. Good job. All right, very good, guys. So anthropogenic, so anthropology is the study of humans, okay, mankind here, and anthropogenic is human-generated, okay? All right, so I put in a little trivia question here. Why do you see fluctuations in CO2 concentrations annually? Okay, so we're going to add a little trivia question here to see if you're on your toes. Why is there a fluctuation in CO2 emissions annually? So that means throughout a year, there's going to be spikes where CO2 emissions are highest and valleys where CO2 emissions are in our global atmosphere are the lowest. Different seasons. Way to go, Cameron. That's correct. Okay. We have different seasons, and we definitely do have more land mass in the northern hemisphere. So that factors in because you have more plants. The amount of leaves on trees. Very good. Awesome, guys. More humans. All right. The more humans, that one's not going to be, it's going to have to do with trees. It's going to have to do with seasonal variations where trees drop their leaves, okay? And so when your tree drops its leaves, it's not actively taking in carbon dioxide and doing photosynthesis, okay? But when a tree has leaves, it is actively taking in carbon dioxide and doing photosynthesis. So when we look back at our graph here, we see this seasonal variation, okay, of carbon dioxide emissions, but the overall trend is going up. The overall trend of carbon dioxide emissions in our atmospheric concentration are going up, all right? There's a documentary out there with Al Gore there, former Vice President Al Gore, but it's called An Inconvenient Truth. And this is like one of the first times that I personally was actually kind of made aware of this particular graph and its influence on carbon dioxide emissions in the future, right? So this is a big one. This particular graph that you're looking at, guys, actually came out of the 2019 free response question, okay? And the question that they were looking at is they were comparing CO2 emissions and pH. You guys noticed over here on the right-hand side of the graph, we see pH levels, okay? So pH is that, if you guys remember, that's that pH scale that goes from, 1 to 14, 7 is neutral, below 7 is acidic, above 7 is basic, okay, or alkaline. And so we're seeing that the overall pH level in the oceans are actually going down, okay? And if pH levels in the ocean are going down, let's do a poll there, Lou. If pH levels are going down, does that mean that the ocean water is becoming more basic, A, basic, or B, acidic? So if pH levels are going down, is that becoming more acidic are more basic. A is basic and B is acidic. I guess I should have said B is basic since it's the letter B. But anyway, you guys are getting the answers right. Fantastic. And the reason I wanted to go over that is because sometimes students forget that pH level goes down on the pH scale, it becomes more acidic. Okay? Good. All right. Let's move on. So carbon dioxide is the major driving force in climate change. And we're going to kind of hopefully tease that out a little bit. Okay.
So Rob, if I can interrupt, is there a connection between the change in the carbon dioxide composition of the atmosphere and the ocean pH level? Or what's the connection between those two?
Yeah, well, that relates right back to that particular question, okay? In this particular question, first students were asked is there a correlation between CO2 and pH level? And students were expected to put that as CO2 concentrations increased, pH concentrations decreased. And so what they're tying into is that the ocean is a carbon sink. And so our ocean stores lots of carbon dioxide. And in doing so, that water that's in the ocean and that carbon dioxide, we get a little chemical equation and the formation of what we know as carbonic acid. And that carbonic acid is, the CO2 levels continue to increase and the ocean continues to try to dissolve the CO2, then the pH level or the amount of carbonic acid is going to continue to increase, which would lower our pH scale, okay? So there is a huge correlation between the two, and that's going to have a really negative effect. Yes, the ocean has the ability to take in carbon dioxide. You have phytoplankton, you have carbon dioxide in the shells and exoskeletons of organisms that live in the ocean and making like calcium carbonate. But the issue becomes when there's so much CO2 and all the phytoplankton are photosynthesizing and all the shells and exoskeletons are formed, that extra CO2 that we're producing as humans is dissolving in the ocean water and making carbonic acid. And so then the pH level starts to go down, and then we have these huge environmental consequences of acidic ocean acidification, which causes that acid will then cause the shells and exoskeletons to actually dissolve, okay, and break them apart. So yeah, there's a huge correlation here. All right. Brenda, you're jumping ahead of me here. You put positive feedback loop. All right, I see you over there. We're getting there. That's close to the end. All right. Okay. How do we address the issue of climate change? Okay. And so if we're saying an increase in temperature or a decrease in temperature or an increase in precipitation or decrease in precipitation, you know, the driving force behind all of that is carbon dioxide. Okay. And so the issue here is how to mitigate. How do we reduce our carbon footprint? Okay. And so there are really, really simple answers that students can use. They can say carpooling, right? Anything that you can do to reduce your carbon emissions will definitely mitigate. And mitigate's a good, strong word for you to use on your AP exam. It means to reduce the impact of, okay? So to mitigate. Carpooling, riding bikes, I mean, those things are just really simple ways to reduce your carbon footprint, okay? If you want, you can go over to the chat box. If you can think of any other ways to mitigate your carbon footprint, start typing those in there and I'll come check them out in a second. The next thing that I would talk about is remediation or bioremediation, okay? How do we restore or try to bring things back to normal? Okay, so in other words, if there was a set quota of carbon dioxide in the atmosphere, how do we maintain that, or how do we get back to that? How do we remediate to that? And that's what remediation is. Okay, And we use bioremediators all the time, and you guys just don't even realize it. We use bioremediation in our wastewater. We use bioremediation on oil spills. I mean, we are constantly doing some form of remediation to the environment all the time. Your bioremediators are living organisms that help bring back the original or the status quo, okay? For instance, for our wastewater, we use bacteria. So when your wastewater reaches the wastewater treatment facility, one of the steps in that process, wastewater treatment, is to release bacteria, and the bacteria are going to break down the organic compounds in our wastewater, okay? When an oil spill happens, okay, we know oil floats, and so we can kind of corral the oil into one location, and then you can literally drop bacteria on top of the oil, and it will break down those large hydrocarbon chains into much smaller, more environmentally friendly chains of hydrocarbons. So bioremediation is definitely something that we constantly do, okay? So that would be something that could use to address our carbon dioxide emissions, or use bioremediators, okay? And that could actually very simply be planting plants, okay? Something that's going to take carbon dioxide in and store it for a long period of time. And that leads us to, I see the chat box is going crazy here. Green roof, stop respirating, Stephanie. I don't know if we're gonna stop breathing, but it's a tough one. Plastic straws, eat seasonally or locally, good. That's a really good one. Nuclear energy, good. So we're getting on to other ways down here with our alternative energy forms. All right, good guys, keep it up, keep it up. I've joked in class and say we're probably never going to pass legislation and say I need all mammals to stop respirating because you're releasing, carbon dioxide. That's probably never going to happen. And remember, when we're talking about carbon dioxide, we're talking about the anthropogenic ones. So the human-generated ones from the burning, 99% of that we're talking about is the burning of fossil fuels, so coal, oil, and natural gas, okay? All right, something that's kind of been really big news in CO2 reduction is sequestering CO2, okay? There are several different ways that we can sequester, or sequester is the AP term for store. And you guys know carbon storage in the form of carbon sinks. And so trees, absolutely, trees can work as a carbon sink. It can photosynthesize and take in carbon dioxide, and then it stores it for a long period of time, okay? And so that's sequestering. Now, there are some drawbacks. You know, do we give up arable land to tree farms that are going to sequester carbon dioxide? You know, at what point do we try to remediate or mitigate carbon dioxide or our carbon footprint, but we also tap into our food resource, okay? You know, it's one thing to, do a tree farm, but if that tree farm is taking up what was cornfields and cornfields were feeding populations, then we're on a slippery slope. And that's one thing that you're going to have to think about when you look at your free response question, if they ask you this, is how can I, what's the best of the both worlds here? Tidal energy, does the ocean store more carbon than trees? Yes, the ocean's going to store more carbon than trees. I don't know in terms of like duration, Cameron, if the ocean stores, like when we think about the carbon cycle is a pretty quick one. Remember, that's the biogeochemical cycle, the carbon cycle. And so photosynthesis is definitely one of those processes in the storing of carbon. I don't remember off the top of my head if the ocean stores carbon longer than trees do, but the ocean in terms of just pure size, okay? Good, yeah, why would you replace plants with that, with trees, just photosynthesize and convert it to oxygen in the plants? Yeah, you definitely could. So when I was saying as far as like converting agricultural land into places that sequester carbon, remember, we're wanting to keep and store carbon for a long time. If you think about corn, we are planting corn, and yes, it does store carbon, but it's a short amount of time because we are cultivating and we are harvesting that corn as quickly, and we're pushing out corn products as fast as possible, okay? So on sequestering, the process would be you are planting something that you want to be there for a long time. So you're not going to harvest. You're going to do zero till or no till agriculture, or you're going to leave the ground fallow where, it's just you're not going to do anything with it. Okay. All right, let's move on to alternative energy, biofuels. Okay. Biofuels are good, right? Stephanie, don't be so hard on yourself. All right. So alternative energy forms. So I saw some people mention nuclear energy. Guys, definitely nuclear energy is definitely one of those that does not produce the carbon dioxide emissions that the other three non-renewables. Remember though, that nuclear is also non-renewable because we're using uranium. So be careful in suggesting nuclear energy as an alternative energy form to reduce carbon footprint when it's non-renewable, because that could be a drawback, okay? Or maybe the free response question says, could you describe one drawback of the carbon footprint reduction method that you mentioned in the question prior to, okay? So one of the drawbacks to nuclear definitely is going to be the fact that it's still non-renewable. There's only a finite amount of uranium on our planet, okay? And we won't get into the whole like nuclear fallout and nuclear weapons and that kind of thing, but those are also negatives to nuclear energy, okay? I talk here a little bit about biofuels, okay? And like say biodiesel versus diesel, right? I live in a rural community, Harrison County, Cynthiana, Kentucky. We got a few stoplights, not very many. We got a McDonald's, right? We're big time in it. We got a super Walmart, that's awesome, right? But we're really not that big in terms of, we're very rural, okay? We're definitely not like an urban city center at all, okay? It's very agriculture based. And so biodiesel or diesel is one of diesel trucks. My students are, they love to drive their diesel trucks, right? And so one of the things I talk to them about my students is biodiesel versus diesel, right? And I think some of my students are in this group, right? Good, Cameron. Lou, are you commenting to Cameron there or commenting to me? Cameron says mining and transportation of uranium can cause CO2 emission. So that is very true. All right. All right, so we're talking about alternative energies. And I was talking about biodiesel and diesel, right? And they both produce carbon dioxide emissions, okay? But the one benefit of the biodiesel is that we plant the corn. If we're getting the ethanol from the corn for the biodiesel, then as long as we continue to plant corn, we're going to continue to sequester carbon dioxide every season. And so the biodiesel that's releasing carbon dioxide is part of a cycle that's going to be taken back up. So why don't we have more biodiesel, right? Why don't we have more biofuel? And that comes back into this part about food production. To what extent do we go down the avenue of biofuels and we set aside, let's say we set aside 20% of agriculture to biofuel production, okay, to reduce our carbon footprint, but that 20% was either feeding people or is feeding livestock or is part of some process that was consumed by human beings. And so we have to, teeter on this fine line of, do we try to help, to what degree are we trying to reduce our climate change issues by reducing carbon emissions and try and feed people at the same time, all right? So maybe the answer would be, well, we just need to produce more crops or more, sugarcane or corn that we can draw ethanol from. And then that leads into, do we have the land for that? And if we do have the land, is that land conducive to growing crops? And if it's not, and you're having to put a lot of inputs and a lot of resources into growing that crop to make the biofuel, then we're looking at a lot of other issues like resource consumption, not to mention the habitat loss and the agricultural formation to make the crops, okay? So there's a really, really tough, some moral, decisions here that have to be made in terms of how do we reduce our carbon footprint, our carbon dioxide emissions in order to reduce climate change, okay? But still maintain the status quo, right? All right, let me peek at the chat box here. I saw two things come in. Biofuels, electric cars. All right, electric cars are a really cool thing. And I would, if you got a pencil and paper there and you're writing stuff down, there's a documentary out there, Who Killed the Electric Car? And I show it to my students just in vignettes. I don't show the whole documentary, but they learn that, these electric cars came out in the 90s, okay, which is mind blowing, right? We had that kind of advanced technology in the 90s. The issue came, it was a big issue with, it was a political issue and motor manufacturing issue and employment issue. There was in the state of California issue. And then eventually you saw the removal of those electric cars. And it had a lot to do with trying to maintain the status quo. But you're seeing now a big push towards electric cars. Now they're not ideal for every location. Okay. Yeah, so that's good, Stephanie. You don't know where the energy could come from. So like here in Kentucky, that electricity that's charging your that electricity that's helping your electric car is probably coming from burning coal. Okay. All right. Legislation. Is there any legislation out there that has influence or has the ability to influence climate change? So go over there in your chat box there and give me some legislation that you've heard of. Maybe you discussed it in class that has had an impact on climate change. And if you haven't, you can chat, I have no idea, or I don't know. So we're in the chat box and we're trying to think of a piece of legislation that has happened. Montreal, Kyoto, both. Good. Montreal. Kyoto. Good, Brenda. The EPA. Okay, good. All right, so let's talk about it real quick. First, I want to commend you on giving me those answers very quickly. You guys are probably ready to do an online AP exam, right? Because your typing skills are very quick. Hey, think about the Montreal Protocol though, okay? Paris Accord, ambient air quality standards, good. The Montreal Protocol was specific in trying to address CFCs, okay? And CFCs were destroying or depleting our ozone layer, okay? And so I would be very careful on discussing climate change and the Montreal Protocol, okay? I would feel much better about talking about climate change with national ambient air quality standards, the Kyoto Protocol. If you guys remember, the Kyoto Protocol was a charge for nations to reduce carbon dioxide emissions. Specifically, it was the first time that any piece of legislation specifically identified carbon dioxide as a problem, okay? Because as you guys have mentioned in this chat box, we can't tell mammals to stop respirating, right? We can't tell organisms to stop breathing that produce carbon dioxide. So you're not going to see, it's very difficult to see legislation in that regard. So the Kyoto Protocol was the first piece of legislation, internationally, right? Because it's a protocol, so it's an international form of legislation, a treaty, if you will, by United Nations that addressed a 20% reduction in carbon dioxide emissions, okay? That was huge. Now, we always talk about it in our classes because we, as the United States, never signed the Kyoto Protocol. And to date, we've not signed the Kyoto Protocol. We had several reasons. One, we are already doing things. We have our Clean Air Acts here in the United States. We have emissions trading. We have carbon dioxide emissions trading. We have things like that that are already in place. We thought that the burden of reducing carbon dioxide globally was on the wealthiest of nations, right? The developed nations were having to fit the burden of having to upgrade coal burning power plants, upgrade how we were converting petroleum into products. We had to figure out a way to upgrade our system, and that put a lot of companies and businesses in economic turmoil, because they would either have to pay for it, or the government would have to pay for it, or ultimately the taxpayer would pay for it. So one of the reasons our developed nation did not sign the Kyoto Protocol is the fact that it was a burden that we felt we did not want to put on the businesses and the people of the United States, and we already had things in place, okay? So it's not that we aren't doing the measures of the Kyoto Protocol, we're just probably not doing them in the same time frame that the Kyoto Protocol called for, okay? All right, so legislation. All right, free response. I'm gonna come out here, take a look at this Colorado Rockies, okay? Trying to, if you guys look at this question here, this was from 2009. It says, this is where I told you my students kind of struggle with hydrology, okay? 2 possible environmental consequences of climate change. So how would climate change in the water cycle, so that tells me exactly what to do. It says climate change and water cycle. So I'm talking about increased temperature, that increases the rate of evaporation, which would decrease the amount of water in the Colorado River system, okay? Increased temperature, that's the climate change, which would cause ice melt or snowpack melt of the mountains to happen too quickly, which could cause flooding to the Colorado River system. So those are some things. So remember, just like I'm saying, I'm stating the climate change, increased temperature, which causes evaporation rates to go up, which is going to decrease the amount of water in the Colorado River system, or increased temperature increases the rate of snow melt, which is going to cause flooding in the Colorado River system. Those are some things that you're looking at. And then the question goes on, it says, what about climate change impacting the water cycle, excuse me, of coastal ecosystems? Now we're talking about increased precipitation, which is going to cause flooding, which could cause saltwater intrusion. Saltwater in coastal ecosystems could intrude the freshwater biomes of swamps and marshes and whatnot, okay? Or you'd say increased rate of evaporation is going to, or increased temperature increases the rate of evaporation, which is going to cause more coastal water to do the whole saltwater intrusion thing again, okay? I had another one here for you. This was 2015, okay? It says climate change could have a variety of impacts on water quality, water quantity, water quality, and habitat. And then it went through a whole process here of describing a negative water quality or a positive water quality, quantity, I keep saying quality, sorry, or a negative quality or positive quality, and then there was habitat here. I'm kind of talking fast because I feel like I'm running out of time. Am I getting close to my time, Lou?
You've got about 5 minutes, Robbie.
Okay. Hey, so I'm not going to be able to go over all of this with you, but what I would suggest for you guys to do, okay, go to the College Board site. You can look up every single free response question. This one is question number 1 from 2015, and this is the scoring guideline, okay? So if I want to like a study guide, this is what I could go and do, okay? All right. The last thing I was going to put up here was positive and negative feedback loops. Brenda, you mentioned it earlier about positive and negative feedback loops, and that is correct. Climate change is one of those things. It is such a controversial topic because you have one group of individuals that would say climate change is this feedback mechanism and it's going to right the ship eventually. Or our environment goes through these cycles all the time where we increase and decrease temperature and precipitation, and so it's a natural mechanism, right? And so I wanted to address what a feedback mechanism is. And so a positive feedback mechanism, you have whatever the stimulus is. You have a response and then the continued response. So in this case, what if the climate change was increased temperature, which increases evaporation, and then that evaporation, okay, causes more increased temperature. Take, for instance, the polar ice caps, okay? If I have a polar ice cap, it's the water around it is absorbing sunlight, causes the ice cap to melt, which increases the amount of water that can still absorb sunlight. It's going to warm up and melt even more snow. So you're going to have a continuation of the melting of the snow cap, okay? Or you could look at it from a negative feedback, where you have a stimulus response and the stimulus is ended. So if I had an increased temperature, which increases the rate of evaporation, which then leads to condensation in the atmosphere, which forms clouds, that's going to actually decrease the temperature, okay? I also teach anatomy and physiology, and sometimes it's maybe easier to think of positive and negative feedback loops in that regard. You know, if my body is cold, all right, that's the stimulus. I respond by shivering, and that causes me to increase the rate of metabolism, then I'm going to actually warm my body up. So that's a negative feedback mechanism, okay? You guys, yes, I mean, there's a lot of different examples out there, and I'm about out on time here, but one thing I wanted to mention here towards the end. Okay, yeah, the mock exam, good, Leslie. That's what I was getting ready to say. Hey, real quick, remember the mock exam, you've got 2 responses. Those 2 responses, you've got 2 responses, you got 45 minutes. You got 25 minutes to answer the first question, and you have 5 minutes to upload your response. After that, you have 15 minutes to answer question number 2, and you have 5 minutes to upload that response, okay? So I've been stressing really hard with my kids, make sure you have a keyboard. If you don't have a keyboard, let me know. I'll get the school to loan out a Chromebook to you. I don't think you're gonna have a lot of success trying to type this on your cellular device, okay? So again, 25 minutes to answer the first question, 5 minutes to upload your response, 15 minutes to answer the second question, and 5 minutes to upload your response. You need to log in 30 minutes prior to the time of your exam, which is at 4 p.m. So you guys need to be logging in at 3:30 Eastern time to take your AP exam, okay? Any questions?
And let me just break in here, Rob. You're talking about the instructions for the actual exam that the students will take in May. We will be offering an AP, an Advanced Kentucky mock exam to practice, and we won't, you'll be doing that with your teacher through AP Classroom, but we will look at the times and encourage you to practice how to respond and what to write.
Appreciate it, guys. That's all I got. Good luck.
Well, thank you so much. And this will be archived on KYAP 2020. Your teachers will know that. But thank you, Rob. That was terrific. And students, be healthy and good luck. Bye-bye now.
Bye.